Hi viewers, this is Electronics Hub instructor team from Kamraj College of Engineering and Technology. Today we shall see the experiment on study of logic gates.
Next we shall see the next gate, which is the NOT gate. It is otherwise also called as the inverter. Why it is called as inverter? The output of the NOT gate will always be the complement of the input. It is having only one input. The output will always be the complement of the input. That means if you are giving logic 0, output will be at logic 1. If you are giving logic 1, output will be at logic 0. So it is represented as y equal to a complement. This is the Venn diagram of NOT gate. Similar to that of the AND gate, this is also a 14 pin IC. 7 is the ground pin and 14 is the VCC. In case of AND gate, it was a 2 input gate, so it is having a 4 number of gates inside one IC. Here there will be 6 number of gates in the IC. Why? Because it is having only a 1 input. So here 1 is the input, 2 is the output, 3 input, 4 output, 5 is the input, 6 is the output. Similarly 9 will be the input, 8 is the output, 11 input, 10 will be the output, and 13 will be the last input, and 12 is the output. So we will be having a total of 6 gates inside one. The application of these gates is in the inverter. In this modernized life, we all have inverter at home. We know that the inverter will be connected to the main supply. So whenever the supply goes off, what happens? The input to the inverter will be at 0. There will not be any input to the inverter. So what happens? The output of the inverter will be high. That is why we will be getting supply whenever the main supply goes off. Next case is the case when the power supply is available at the inverter input. So what happens? The function of inverter is always the negation. So the output will be at 0. So the inverter will be in the off state. So the output of the inverter will be 0 and the supply will be available from the mains itself. So this is the application of the NOT gate. That is, whenever the supply input of the inverter goes 0, the output will be high, so we will be getting supply. And whenever the input to the inverter is at high state, that is the mains is in on state, the output will be in 0 and the current will be obtained from the main transformer itself. This is the workbench. You will be working with this bench only whenever you are doing any experiment. So for that it is having a main supply, but turn on that main supply. Then you have a trainer kit. You have to turn on that supply also. The trainer kit will be having additional separate main switch. This is the VCC and ground. It is available in both sides. You have 5 volt VCC and 12 volt VCC available, and corresponding to that you have ground buttons also available. These are your input. Corresponding to each switch there is an LED. The LED off and on condition indicates whether it is in the input is in logic 1 or logic 0. These are the output. Corresponding to the output also you have some LEDs. The state of the LED indicates whether the output is at logic high or logic 0. This is your clock signal. Now we can see how to check the NOT gate. This is the NOT gate. So previously I have told how to identify pin number 1. Below the notch, the pin indicates the pin number 1. This is the pin diagram of NOT gate. It is having only one input. Pin number 1 is the input and pin number 2 is the output. So we can see how to connect the VCC ground input and output to the IC. So here inside this you have a small hole. Insert your wire inside the hole and close this. This is your 5 volt VCC. Connect it to the same column of the 14th pin. Next, similarly you may connect the ground and the input. Ground is in pin number 7. You have only one input, that is in pin number 1, and only one output, that is pin number 2. Now turn on the trainer kit. I have given this as the input. You may see that LED is in the off state. LED is not blinking. So the input is 0. So for a NOT gate which acts as an inverter, if the input is in 0, output will be in logic 1. So the LED has blinked here. Next, I am making the input high, turning on the switch to the high state. If the input is high, output will be in 0. So the LED is in the off state. This is the AND gate. Similarly, you may check all the other 5 gates that is available with the IC. Similarly, we may check the gate with giving 9 as the input and 8 as the output. You can see that the input is at logic 0, so the output is at logic high. When the input is in logic high, output will be at logic low.